Hello everyone. This week I'm going to be doing a slightly different video. That is, I'm going to actually talk about my day job. So today we're going to be talking about 5 basic data structures that every programmer should know. And if you're not a programmer, that's okay, you don't have to stop the video, please don't. This is a good way to learn just a little bit about programming. It's not going to be that intense, I promise. I'll try to explain everything in layman's terms. All of these data structures, first of all, are going to be talking about the same type of data. Now, type in programming is very different from what you might be thinking. So a typed language is one, not that you type out, of course. It's where the programming language requires you to make a distinction between a number and text and other kinds of data. So the first data structure we're going to talk about is also the most simple, an array. An array is a fixed size, and it just contains some number of those elements of whatever type. Some of the advantages of them are that they take up a fixed size, so you can go with a predictable spacing and go, oh, I want the third element, give me that third element. So they're very good for random access and things like that. The problem is, as I said, they're a fixed size. So if you don't know how many elements you're going to have to deal with, they're not necessarily the best data structure to use. And as good as they are at random access, if you need to find something in there, you generally have to look through the whole structure unless there's some sorting applied or something like that. The next most important data structure, in my opinion, is lists. Now, lists generally have a dynamic allocation. That is, they can be as big or as small as you need them to be within the constraints of whatever memory you're dealing with. Depending on the underlying implementation, it may be challenging or easy to do random access. It may be easier to go iteratively through the whole thing. It depends on the application and the implementation. The next data structure is also similar. It's called a set. Now, a set is sort of like a list in that it has dynamic sizing, but like in math, a set can only contain one instance of each unique item, as opposed to a list or an array where you can have multiple instances of the same data. A set is generally considered to be unordered, but there are variations in which the underlying implementation allows you to iterate across them in some particular order, sorted, the order they were added to the set, things like that. The fourth data structure that I think is important for every programmer to know is the map. Now, a map takes a set of keys and maps them to some set of values. The keys and the values can be different types, they can be the same type, whatever the application requires. The idea is that you come into this data structure knowing something about the key and you're wanting to get information about it. Think about it as if you were trying to look up an order that you placed on a website. So you type in that order number and you get back the order details. That's a map. Somewhere there exists some mapping between that order number, that key, and that value, your order. And finally, the last data structure that we'll be talking about today is called a tree. Now, a tree is sort of like a list, but it has multiple child lists that spread out from it. You can, of course, do multi-dimensional arrays and multi-dimensional lists, arrays of arrays, lists of lists, things of that nature, sets of sets even. You can even do crazy things like maps to maps of maps. But a tree is a little bit different. There are, of course, variations on this, like there are for every data structure, because of the multitude of problems that we have to solve in computer science. The place where most people are likely to encounter a tree structure is in their hard drive. So you have a folder, and that folder contains other folders, and then you go to those other folders and they contain other folders and files and things of that nature. That's a tree structure. The basic idea of a tree is that you start from some point and go further down in some direction or another. If you were to draw the whole thing, it would end up looking kind of like a tree. And that's all for this very quick video about data structures. This is a new thing on this channel. I'm not sure if I'm going to keep it up. If you have an interest in watching more videos about programming, I'd be more than happy to talk about it. It's very interesting to me. And I hope that you are all finding it interesting as well. Thanks for stopping by. I hope you'll join me again next week when I talk about something else that I find interesting. Until then, stay curious.